Hello everyone, I'm Xiaogan. We can see that if you have an actor class, it actually has a tick. Its corresponding tick function is this one. So why do we have to call super? If you don't call super, you'll find that this function won't execute. If this function doesn't execute, it will cause your blueprint to be unable to call the tick of the blueprint class. So that's one reason for this. Also, it's worth noting that there is a lot of source code related to actor. It explains the life cycle of this actor. And actually, this entire series of lifecycle events is just like the diagram in our official documentation, where the actor has a lifecycle diagram. Generally, during interviews, they will ask you about this actor, its entire initialization process, and its relationship with components. How do they get from the hard drive, or spin actor? How do they complete such an initialization lifecycle? You can see that it ends with BeginPlay. Before that, you can see first time has a loading, then the creation of this component, then pre-register all components. Then components start registering. After the components are registered, now the actor is created. Then the constructor starts here. Then components are initialized here. Then the component is activated. Then component activation. Then the component initialization is complete. Then finally, there is BeginPlay. Roughly this flow. Everyone can refer to it and take a look. Okay, our main focus is to talk about tick. You will notice that in this place, it is called what? UClass. UClass does not have the tick capability. So how do we extend it? Actually, if it's very simple. If we were to write it ourselves from the very beginning, you can do it entirely here. Write a tick function. Then just find any global unique, for example, game instance. A place like that. Then manually call it. Then in the game instance, let's take or in the tick of this actor. You can just manually call it, but this might not necessarily guarantee execution once per. Sometimes it may execute multiple times in one. This kind of situation is the reason for this situation is mainly that you may have been called multiple times. The engine actually provides a way to help us implement this functionality. So you just need to inherit from this interface. Just inherit from it. You see it. And what is it? This class provides the ability to tick on the get thread. And this is an abstract one, requiring you to implement the two methods, tick and GetStatID. You can also tick in the editor. And at the same time, it allows both the editor and runtime to tick. So if we mainly need to override it, the method to override is mainly here. Here we rewrite this tick method. Yes, and then there is also a tickable. That is, whether it can tick. And then also this GetStatID. Okay, so now let's rewrite it. Okay, and let's try to separate them, because they actually come from different classes. According to the engine's standard conventions, you should put them together and then use comments to separate them into upper and lower sections. Okay, now paste the monster here. So actually it's these three methods, but there is still some details here. Okay. Then, on his side, the default is this for force. We need to change it. You can see here. Actually, this place. You can just not remove it. This super, because there doesn't seem to be anything in its super, because it's a virtual method. You can see it must be overridden. So there's no need to call super here, because he didn't write anything. You can't adjust this super either. Then here we need to make a simple judgment. That is, if it is not a CTO object, we will, if it is this kind of CTO, we will not let it tick. Yes, to make a simple judgment like this. Then the stated here, we need to do a simple processing. Then here, writing stated like this is fine, like this. Okay, put it here. Okay, now let's compile it. It's okay. No issues. Actually, if you don't know, sometimes you don't know how to write these functions, we can still use our old method. You can do a global search like this. Then you'll find, look, right here, some overrides have been done here. Then take a look at roughly how it's overridden. Then you'll basically understand So this is a relatively direct way to write it. That is to say, it's a very useful method. Take a look at what it wrote for you. What is the name of this class introduced here? And how is the example in the comment written? You can just search for it in the engine, and that's fine. Then, for this part, let's print a logger for everyone, because it seems we can't think of what functionality to implement in this tick right now. Actually, there is still a lot that can be done within this tick. For example, sometimes we might need to execute something every frame. Check how many NPCs are in our scene, or how many monsters there are. If it reaches a certain number, then we execute the next step of the logic. That is, if you have this kind of per frame requirement. If you have this kind of frame by frame requirement, the execute. And if you don't have such a need, actually it's best not to write too much in tick. We often pay attention to this kind of thing. If you log in tick, and also perform tasks in tick, and cast reads in tick, these things are actually quite costly in nature. So everyone should avoid doing these operations in tick. Sometimes we have an operation like this. We have something called a boolean tick operation. We'll demonstrate it for you in a moment. We can take a look. Let's just open any map, no need to worry. And then we can see, actually if you look at the very bottom, this test is equivalent to executing every frame. You see, this test comes from our blueprint. Look at the user message of log boot point, and this log term warranties actually comes from this place. Then you can clearly see it executes every frame, which is exactly the same as our main thread. The main thread executes once per frame. So this logic is correct. And then sometime you might, if this happens to execute twice per frame, then you might check if there is something wrong with the CDO, or you have an external call, and then actually we go write standalone programs. We will explain to you later. When you write a standalone program, your engine is not a complete engine, because when you write a standalone program, your engine may not have audio rendering or scene rendering. Maybe at most you have an HTTP module that needs to tick. At that time you can manually tick, but doing so will cause the engine to get stuck on this frame forever. That is, the engine is actually written incorrectly at this point. If you manually remove the tick, the engine will keep stuck on this frame. Don't do this! You still need to let the engine advance frame by frame. Then at this point, you don't need to manually tick some modules. For example, the audio module, for example, the HTTP module, or the multi-thread module. Then it will follow the engine's underlying mechanism to tick frame by frame. That is not correct. Okay, here I will introduce a way of writing this. This way of writing is also quite common. Generally, people who use C++ particularly like this style. We will give a boolean bFirstTick. They will write it like this. They like to write, if it is not the first frame's tick. If it is the first frame's tick, we will perform such an operation. Tell it here. If it is the first tick, okay, then we set it to false. Then we perform some initialization operations. Yes, sometimes they do that because of BeginPlay or this, because it's that one branch. Well, it is sometimes unstable, because you cannot guarantee the order of execution, especially for actors. You cannot guarantee that BeginPlay will always execute first, because in a game, this is not clear-cut. So it might also be done on the first or second frame. So this is often seen sometimes, but actually writing it this way is not very reasonable. The correct and reasonable approach is, there is something called gamma framework, a kind of advancement. Actually, in another week, you will see. When he deals with problems in the sequence, he will make a correlational advancement. Well, this part is quite complex. We won't include it in this lecture. Just to mention it to you, you roughly know. There is such a situation, then our gamma instance subsystem will be briefly introduced to everyone. That's all for this part. Actually, there are many extensions. For example, how to use the engine subsystem or editor subsystem or oral subsystem. For these, you can just look up articles or search for them when you need to use them. They're mostly similar. We mainly focus on this. Then we will have a lot of cases later, all using this type of game instance subsystem. Alright, we'll stop here for this lesson.